This is the second part of the section 7.2 lecture. We're now going to talk about finding confidence intervals for mu when we don't know sigma. To do this, we are going to use the calculator, and we are going to go to the stat menu, choose tests, and choose t interval. This is similar to what we did in 7.1. In 7.1, we chose z interval. In 7.2, we are choosing t interval. Now, some requirements remain. We have to be able to assume that x is normally distributed, or it's at least mound-shaped and symmetrical. And if that's true, n can be any number. If we can't assume this, then n has to be greater than or equal to 30. Our margin of error is the same that we have found before. It's the same formula, except instead of z sub c, we have t sub c. To find t sub c, we are going to use our formula that we saw in the previous video, which is this. T sub c equals c plus 1 minus c divided by 2. So if we wanted to know t sub 0.8, that would be 0.8 plus 1 minus 0.8 divided by 2. Degrees of freedom will be n minus 1. So suppose an archaeologist discovers 7 fossil skeletons from an unknown species of horse. Reconstructions of the skeletons show the shoulder height in centimeters to be the following 7 numbers. For those sample data, the mean x bar is 46.14. The sample standard deviation S is 1.19. We want to know from this, what will mu be for the entire species of horse? We're going to assume that the population is approximately normal. So we have a sample standard deviation. We do not have a population standard deviation. So we want to find a 99% confidence interval for mu, the mean shoulder height of the entire population of these horses. The first thing we do, check our requirements. We are going to assume that these reconstructed skeletons form a random sample. Also, the x distribution is assumed to be approximately normal. Since we don't know sigma, we can use a student's t distribution and the information from the sample to compute a confidence interval for mu. So here's how we do this on the calculator. We go to Stat, choose Tests, go down to option 8, which is t interval. Make sure Stats is what's flashing, and then we enter in our data. X bar, our sample mean, is 46.14. S, which on the calculator is capital S, that's our sample standard deviation, that's 1.19. N is 7. C level is confidence level on the calculator. So that's 0.99. Then we go down, we choose calculate, and we see our results. Our interval is 44.472, comma 47.808. So what this means, we're rounded here a little bit, is that the archaeologist can be 99% confident that that interval from 44.5 approximately to 47.8 centimeters is an interval that contains the population mean mu for shoulder height of the species of horse. Again, the confidence level is the interval that is one that contains the mean. So our confidence interval, this is very similar to what we saw before. How can we find E? How can we find what our maximum error is? Depends how much we know about the X distribution. The most common situation, you don't know the population standard deviation. So here you use the t distribution and you use this margin of error. E equals t times c, E equals t sub c times the quantity s over the square root of n. Degrees of freedom is n minus 1. you'd have to follow those guidelines we talked about already if it's less than 30, but if it is more than 30, you're fine. This is when you use t-interval. The other situation is when you use z-interval. This is what we did in 7.1. This is rare. Read the problem carefully. If the problem tells you what sigma is, you are probably going to use z-interval. If the problem doesn't tell you what sigma is, you are probably going to use t-interval in the calculator. If you need to find the margin of error, this is the formula you use. T sub c times s over the square root of n. Let's end with an example from the book. All right, this is number 14 on page 383, talking about sleeping bag costs. So here's a random sample of prices for sleeping bags that are effective from 20 degrees to 45 degrees Fahrenheit. We're going to do B and C. You could do A on your calculator if you wanted to. You don't need to do that for these problems. You can assume that what the book tells you is correct. So we're going to use this data as a representative of the population of prices of all sleeping bags in this temperature range. We're going to find a 90% confidence interval for the mean price mu of these sleeping bags. So what do we have here? We have X bar, we have S. We don't have sigma. That means we're going to use what type of interval? That's right, we're going to use a t-interval because we have S instead of sigma. So I'm going to go to my t-interval, make sure I have stats. I could, if I wanted, use a data list. I could dump all of these into the calculator and use data, but we aren't going to have to do that for this. We're told that X bar is 83.75. We're told that the sample standard deviation is $28.97. And we have, let's see, 2, 4, 6, 8, 12, 16, we have 20 sleeping bags, if I counted that correctly. And our confidence level is going to be 90%. So when we choose calculate, we're going to round these to the nearest cent. So our range would be from $72.55 to $94.95. That would be our answer for B. Our range of prices would be from $72.55 to $94.95. And now we're going to interpret. What does this interval mean in the context of this problem? This means that we are 90% confident that this interval is one of the intervals that contains the population mean price of summer sleeping bags. It doesn't mean we're 90% confident the mean price is between this and this. It means we're 90% confident that this interval is one of the intervals that contains whatever the actual mean price is.